We're going to be looking at the double angle identities. Now there's a few of them, so you want to make sure you pay attention. The first we're going to take a look at is the sine of 2a. The sine of 2a, we can always write this, we will rewrite this as 2 sine of a cosine of a. And then we have the tangent of 2a. Now we're going to do tangent before we do cosine, because cosine can be written a number of ways. Tangent becomes just 2 tangent of a divided by 1 minus the tangent squared of a. And now the last one we're going to take a look at, of course, is the cosine of 2a. Now the cosine of 2a, the first one we're going to take a look at is just this one. Cosine squared of a minus sine squared of a. That's the 2. Now, if I were to replace my sine with 1 minus cosine squared of a, that allows me to rewrite it this way. I can get 2 cosine squared of a minus 1. And if I switch my cosine squared with 1 minus sine squared, that gives me 1 minus 2 sine squared of a. Now for the next few problems, we're going to take a look at this little step right here. They give me alpha and they give me beta. Now they tell me alpha lies in quadrant 2 and beta lies in quadrant 4. So before I answer these questions, the first thing I'm going to do is draw our triangles. For alpha, we know it's in quadrant 2, so I draw it in quadrant 2. It's opposite over the hypotenuse, which makes this side right here negative 4, because my x value is negative in the second quadrant. For beta, it's in quadrant 4. It's the opposite, negative 5, over the adjacent, which is 12, which makes our hypotenuse 13. So, solving the problems here, if I want to find the sine of 2 beta, so this is the triangle I'm looking at, my rule says I can write this as 2 sine beta cosine beta. And that's how I'm going to write that. 2 times the sine of beta cosine of beta. And I just plug in my values. Sine of beta is negative 5 over 13, while the cosine is the adjacent 12 over 13. And I can just multiply those together here. The bottom becomes 169, and the top becomes negative 120. So this becomes negative 120 over 169, and that's going to be the sine of 2 beta. Now, tangent's a little harder to do. This becomes 2 times the tangent of beta over 1 minus tangent squared of beta. A little bit tougher. So I get 2. The tangent is the adjacent over the, it's the opposite of the adjacent. So I get negative 5 over 12. Over 1 minus the tangent. So this becomes, if I square this, I get 25 over 144. Yuck, yuck, yuck. So this becomes negative 10 over 12 over, and if I do a common denominator, I can get 144 minus 25 over 144. And the reason I do this is now I'm going to multiply both top and bottom by 144 times 144 gets rid of my fraction. Cancel become 12. I get negative 120. Cancel, cancel. Whatever this is equal to, 144 minus 25, that is just equal to 119. And there's our answer. So we get negative 120 over 119. This might be one you want to do again, not because of plugging in, but because of the arithmetic. All right, so for class tomorrow, please go ahead and finish up number 3. Okay, so type pause it right now and finish up number 3. Okay? All right. Down here, if we want to express these in terms of sine, cosine, tangent in a single variable, very easy to do. Now be careful. The trickster I am, number 4, if you recognize, it's not my double angle. Nope, that's just my old sum and difference, because I want you to remember the difference between, for tangent. This is saying it's the tangent of A plus B, plus or minus B. And remember, for tangent, whatever sign that is the one we use. So this is the tangent of 60 minus 45, which is just the tangent of 15 degrees. Be careful, tangent's different here. Right. Now, for number 5, now, easy to recognize. Sine is always going to have 2 sine cosine. Cosine is tangent, always going to have tangent in it somewhere. But cosine is one of 3 choices. So this is our cosine of 2a. So it says to do, well, there's my a. So I'm going to write it as the cosine of 2 times pi over 12, which becomes the cosine of pi over 6. Now they just want me to simplify, express it as a single term. But if you want to, you can simplify that. Cosine of pi over 6, root 3 over 2. But you can just leave it as the pi over 6 if you want to. Our next one, here's our tangent. Our sine of 2a. Of course, you notice there's my a, there's my a. If you know all this stuff, you too will get an a. This is just our rule for sine of 2a. And it says just write it as a sine of 2 times a, pi over 9. Which I really can't simplify that too much. I just get the sine of 2 pi over 9. And there's our answer. Number 7, it's our tangent of 2a. I feel Canadian. This becomes the tangent of 2 times 45, which of course is the tangent of 90 degrees. You can leave it as 90 degrees for this one, or because we know that one, it's undefined, we can just write it as undefined. Funny joke. How did they get the spelling of Canada, by the way? C-A-N-A-D-A. All right. Wasn't all that great. So, simplify and evaluate. Now, evaluate means I want to get an answer. I want to go an answer. I want to go all the way I can. You should hopefully recognize that this is our cosine of 2a rule. So we're going to get the cosine of 2 times pi over 6, which becomes the cosine of pi over 3. And what's the cosine of pi over 3 going to be? Me, you, t. All right. Very good. It's 1/2. Nice job. All right. Try this one. Oh, it's our sine angle. Oops, sorry, that's again our cosine. Boy, we like that cosine one a lot, don't we? This is our first cosine one. It's the mother of all cosines. This is where all the other cosines come from. This becomes the cosine of 2 times 60. Don't get confused. That's the cosine of 120. And I like radians. 120, remember, that's my 30-degree angle that's my 30-degree angle in quadrant 2. So this is a pi over 6, and it's in quadrant 2, so it's 5 pi over 6. Cosine is negative in that quadrant, and we get negative root 3 over 2. All right, very good. All right, now, for the next few problems, please make sure you go to part 2. Now, I noticed some of you guys haven't been watching all of part 2, but you need to watch part 2 to go over the next ones, especially number 11, okay?